So, as Dr. Klemner said, my name's Olivia. I'm a genetic counselor, and some of you might be wondering what that even means. So just quickly, before I get into my lecture, I just wanted to explain that a genetic counselor is an allied health professional who usually has a master's of science in human genetics or genetic counseling or higher level education. Sometimes they may be nurses also. And our role is to assess whether a person's cancer or their family history of cancer, or both, suggests that there might be an underlying predisposition that's running in the family. And so I would meet with a person or someone like myself. We'd review someone's history, personal and familial, and then discuss our assessment and our opinion and walk them through genetic testing options, facilitate testing, and then the important part, when the results come back, interpret them. So that is what a genetic counselor does, and that's what a genetic counseling visit entails. Just a tad bit of genetic science, nothing crazy. There's not going to be any tests. Essentially, if you remember nothing, you just need to conceptualize that genes are like sentences. They tell the body to do something specific. And all of the genes that I will touch on today, we have them all. It's a common misconception that we either have them or we don't. But actually, we need the genes that are involved in cancer predispositions. Most people have these genes and they're working properly. Again, like a sentence, we need everything spelled properly and the words need to be in the right order. If there's a mistake inside your sentence, the body's not going to understand what the sentence is telling the body what to do. And so the job primarily, generally speaking, of these genes is to protect against the development of cancer. We have 2 of every gene, which I think is really great because it's a built-in backup. You get 1 copy from one parent and 1 from the other. Now, there are lots of genetic tests out there. I'm talking about clinical genetic tests, not 23andMe or Ancestry. Just to clarify, the take-home about, generally speaking, how clinical, medical, diagnostic genetic tests work is that they analyze a certain number of genes in a very detailed way, and they're looking for any difference at all in your set of genes versus the dictionary, generally speaking. And I've bolded here and also made a graphic. I'm going to be focusing on positive results, and the definition of a positive result is a problematic change, going back to our analogy about sentences, a spelling mistake, a typo, that a person likely inherited, not always, but likely inherited, and then can pass on to their relatives, or should I say children, or may share with their relatives. Most cancer predispositions, and in the case of gastric cancer, hereditary gastric cancer, follows dominant inheritance. So this means that a person typically has 1 genetic likely inherited problem in 1 copy of their genes, but the other one works and is still protecting them against the development of cancer. Because there's only 1 gene that has a problem, that translates to a 50% chance that if you have a positive result, your siblings, parents, children would have the same finding. Now, we are still learning a lot about gastric cancer in general, but primarily hereditary components. And it's actually quite rare to have we think, a hereditary predisposition to gastric cancer. So more recent data suggests perhaps that there's about a 3 to 5%, or should I say 3 to 5% of cases of gastric cancer have a hereditary component. And I want to define that. From my perspective, a hereditary component is a genetic problem that we can identify, usually in 1 gene. And I've made a little chart. I don't know how visible it is, but hopefully these will be available for you, where a person, again, has a positive result in 1 of these gene problems. that we know is associated with an increased risk of gastric cancer. And so therefore we would say you have a hereditary gastric cancer, or if that person's never had cancer, a hereditary predisposition to gastric cancer. On the other hand, there are familial components that we don't fully understand that may contribute, must contribute to the development of gastric cancer. When we seek to define familial, we see families that have a pattern that might suggest an underlying single gene problem running in the family, but we do a genetic test on them and we don't find anything. Their result comes back negative. Well, it doesn't mean that it reduces their likelihood, but it doesn't eliminate the possibility that there could be a genetic problem we just didn't include in your test because we don't know about that gene and the link with gastric cancer. Perhaps there are smaller hereditary factors, shared exposures, shared environment. Most people, at least for part of their life, grew up with their relatives. So it's kind of like a gray zone. Familial, about 10% of gastric cancers fit in this category. Now there are, even with 1 to 3% or 3 to 5% of cases being hereditary from a single gene component, that's still quite a few genes I've got listed up here, but we have 30,000 genes, so we have a ways to go. And there's a lot of evidence coming out that suggests that other cancer predispositions, maybe primarily including breast cancer, other cancers may also include gastric, and we didn't appreciate that or haven't realized that or don't have enough data about that at this time. But it's something that's exciting that's coming out, that maybe gastric cancer is part of more genetic conditions than we realize right now. Now, and I also kind of highlight that in this chart here in the first column, that from my perspective, when I meet with someone, I'm thinking about what type of gastric cancer do they have? Is it a more rare type, like a carcinoid, or a gist, depending who you talk to? Or is it an adenocarcinoma, and then even within that branch, is it diffuse type or intestinal type? And so some of the things I'm thinking about for red flags for potential hereditary cause to their cancer is their histologic type. Are there other cancers that that person has had? Do they have a history of gastrointestinal polyps, so in the colon or the stomach, or both? How old is that person when they were found to have their cancer or polyps? And then do they have a family history of polyps and or cancer, or do we not know their family history? Now, sometimes it's a combination of all of these factors that can influence my decision. Sometimes it's only one. If someone's young enough, I don't need to really do too much more digging. Now, who's really the best person to have genetic testing? And that really is the person who's had the cancer. And sometimes people are surprised by that. However, I have a couple analogies. Hopefully this one doesn't fall flat. But if you have a tree with apples, and the apples are usually red, but one day or year or season, you notice that some of the apples are turning yellow, or they grow, and you have some yellow apples and some red apples. You might want to figure out why. Why am I having yellow apples on my red apple tree? You would need to do a test, some kind of investigation into the yellow apples, because they're the ones that changed, to see why they changed. And that hopefully illustrates why someone with a gastric cancer is the best person to do genetic testing, because they have had this finding, which is like a symptom of having an underlying genetic problem. And if we don't know, or maybe they're the first person in their family and we're trying to find the cause of why their cancer happened and could it be running in the family, they are the most likely individual to come up with a positive result. It'll explain the why of genetic testing, of course. It can then explain, this is why your gastric cancer happened, and this is what we need to look out for the future, because all cancer genetic genes seem to be involved with other cancer risks of other organs. For example, Lynch syndrome is basically a predisposition to gastrointestinal cancers, primarily colorectal cancer. It also includes gynecologic cancers, cancers of the urinary tract, and other organs. If we know that a person's gastric cancer was due to a hereditary cause and that they have an increased risk for cancers of other organs that maybe we didn't realize or would think that they have a higher chance for, we want to change their management and keep an eye on those other organs, maybe by having them start screening at an earlier age, consider surgical interventions, or start screening more frequently when they do start. And then, of course, all of this can help their unaffected relatives. In theory, and our true goal is to ensure that they don't end up with a cancer diagnosis if possible. There's a lot to think about when you're thinking about having genetic testing, and it's not just the genetic concepts. It's considering what are the impacts, the medical impacts on me or my relatives. Some of the interventions we discuss are surveillance or screening, but some of them might be considered drastic to some people. There are some gastric cancer syndromes that confer, although we believe them to be rare, some of our genetic testing techniques have pointed out that they're maybe not as uncommon as we thought. For example, hereditary diffuse gastric cancer syndrome, primarily thought to be caused by a problem in the CDH1 gene, confers such an intense and strong increased risk of gastric cancer over someone's lifetime, and we don't feel confident in our ability to screen for that technique that we actually do recommend prophylactic, meaning before cancer is even on the radar, removal of that person's stomach. So removing a healthy person's stomach, which is, I usually get a lot of really crazy looks when I mention that. But the reason we do that is because we have the benefit of knowing what someone's risk is ahead of time, and we want to, if we can act on that, we want that option to be available to that person if they really think they would want to do it. So there's a lot to consider medically. It could change someone's current therapy, perhaps, potentially, but that's perhaps less common if someone already has a cancer. There's obviously a psychological impact. Learning that you have a predisposition that a relative may share with you. And I hesitate because it pains me so much to hear the guilt from a parent or a sibling or even someone who doesn't have the predisposition. No one chooses to pass on genes. It's inherited. Passing is like, I'm giving this to you. Merry Christmas. No, it's not on purpose. But that could still weigh on people, and it can take a long time to adjust to that. And then, of course, families in general. How do I explain this to my relatives? I'm also not talking to certain people for other reasons. I don't want to have to bring this up. There are a few things going on that I encourage everyone to just think clearly, consider your own personal situation. If you're thinking about doing genetic testing, how each of these different factors may weigh on you or not. And then, of course, the last one is for an unaffected person, meaning they've never had a cancer and they're thinking about learning if they have a predisposition to cancer, whether it's known or never been identified in the family. It can impact their ability to get life insurance, which some people worry about and some people don't. There are protections, which I won't get into details just for time, but there are protections against discrimination in the employment realm and in medical insurance realm as well. So non-discrimination, of course, means they can't treat you any differently, but it's not the same thing as privacy. And I'll just leave it at that. So if you're thinking about genetic testing related to the cancer in your family, or you're not sure if it's even relevant for you, I would obviously discuss with your care team and think about meeting with someone like me, a genetic counselor, or a genetics professional, because genetic testing options are complicated. So is insurance. That's a moving target. There are lots of options that a person can choose to take advantage of for either of those. A multi-gene panel that looks at many, many genes at once. You may want to use your insurance to pay for testing, you may not. A lot of people have coverage. These are things that genetics professionals have a lot of expertise in because we deal with it day in, day out. And then, of course, dealing with the results and how they impact your life going forward, and we can help with that too. So with that, I thank you for letting me do a brief overview. I've provided some resources up there. You're welcome to contact me by email if you have any questions, and I'll be around later today. Thank you.